Seventh grade honors class, we begin Unit 8, Personal Finances with Calculating Interest. So we're going to go over two different kinds of interest. Preston earned $2,000 over the summer working as a lifeguard. If Preston wants to save the money he earned, list some of the benefits of depositing his earnings into a savings account rather than keeping his money at home. Okay, let's see. What's the benefits? His money is safe. His money is safe in the bank. He will probably not waste it on anything. And anything else? Oh, he's going to earn interest. He will earn interest. Interest or additional money that you earn. Yep. Additional money that you earn for keeping your money in a savings account is earned regularly and is expressed as a rate or percentage. So when people talk about an interest rate, they're usually going to give that to you as a percentage, like 5% interest, 10% interest, and so on. Review the two types of interest and the formulas used to calculate them in the table below. Simple interest. So for this one, we're going to find out the interest that you earned. So let me just write the words here. By calculating the principal, sorry, that's the first amount. So the initial amount that you put into a savings account is called a principal. So for example, when Preston was thinking about putting $2,000 into an account, that's the principal. The first amount or the initial amount that you put in is the principal amount. And we take the principal times the rate, and we express this as a decimal. So I said that the rate, people talk about it as a percent, but when we write it down, when we write it in a formula, we have to convert that percent into a decimal. Okay, basically just move the decimal over 2 spaces to the left. And then we multiply that by time. So interest equals principal times the rate times the time. Okay. Simple interest is interest earned only on the principal or original amount deposited into the account. So in other words, simple interest is slowly, steadily earning interest. Okay, you earn interest in a steady way, but it tends to be pretty slow. Now we're going to learn about compound interest, which is much faster. So for this one, we're going to calculate the account balance, not the interest earned, but the account balance at the end. You'll see the difference after we do a few examples. So the account balance A is equal to the principal. There's that first amount again. I should probably write that down. Principal is the initial amount times the rate So let me say that again. The account balance equals the principal times the quantity, 1 plus the rate raised to the t power, and t is however many years. So I should put that down also. Time is expressed as years. Okay. Account balance equals principal times the quantity, 1 plus the rate raised to the t power. Compound interest is earned both on the principal plus any previously earned interest. So in other words, when you put in a certain amount of money, a principal, and you earn compound interest on it, instead of simple interest, this grows at a faster and faster and faster rate. So we could say that compound interest grows your money exponentially, not in a straight line, but it grows it exponentially, faster and faster. When calculating interest earnings, it's important to ask yourself the following questions. Which formula do I need to use? Will the formula used give me the interest earned or the account balance? And what exactly is the question asking for? Use and apply the formulas above to calculate the interest earnings below as well as the total balance of the account. Assume that no other deposits or withdrawals were made. So let's do the first example, and then you'll see that we're really just going to plug in the values, plug in the numbers into these formulas and figure out how much money was earned and figure out the new account balance. Ahmed deposits $600 into an account that earns 2% simple interest for 30 years. All right, let's plug this into the formula. So we're going to find the interest that he earns. I equals P times R times T. We're going to have $600 times the rate. Remember that the rate is the percent, but we have to change this into a decimal in order to calculate it. So 2.0%, we got to move that decimal over 2 spaces. So I'll just do that right here, okay, as an illustration. And we get 0.02 as a decimal. And then we multiply that by the time, 30. Okay, so you type this into your calculator. Oh, you know what? I should be writing this down right here. Excuse me. So I fill in the values, 600 times 0.02 times 30. And once we type this into our calculator, so I recommend for these interest formulas, use the Desmos calculator, because you'll be able to use the exponents much easier. You'll see it when we do the compound interest. So we type this in to our calculator and we see that he earned $360 interest just by keeping his money in a savings account here. He earned $360. And then now we add 360 to his principal amount. The original amount was $600, and then he earned $360 after 30 years. So now he has a balance of $960. Without doing anything, he just kept his money in there, and it slowly earned more and more interest. So now we're going to do one that shows compound interest, how the money can grow faster and faster. Sasha makes a $2,400 deposit into an account that earns 4.5% interest compounded annually for 8 years. So let me just underline those. So our formula again is A equals principal times the quantity 1 plus the rate raised to the t power. Let's fill in our values. A equals, the principal amount was 2,400 plus 1 plus the rate is 0.045. We're going to move that decimal over 2 spaces to the left. 0.045 times the rate of, or times the years, 8 years. Oh, no. Let me put that 8 as an exponent. Sorry about that. I was rushing a little too much. Okay, so let me put the 8 up here as an exponent. Okay, so this is when you want to use your Desmos calculator, so you can calculate the exponent right here much easier instead of typing in 1.045 times 1.045 times 1.045 8 times, we can just use the calculator and type in to the 8th power. So if you have any trouble with that, I don't have a computer in front of me right now. If you need a little bit of help with that in class, please let me know. I'll show you how to type in those exponents. So the interest earned after we type this in is going to be $1,013.04. And we add that to the principal. We add that $1,013 to the first amount, and we have the sum of $3,413.04. Okay, that's the new account balance. All right, so let me do a few more examples on the back side of this with you, and then you can do the rest of the homework on your own. Use the interest formulas to calculate the interest earnings below, as well as the total balance of the account. Assume that no other deposits or withdrawals were made. So just like the last problem, a $5,400 deposit for 11 years, earning 4.25% simple interest. Okay, our formula again, I equals PRT, and we can plug in our values of 5,400 times the rate of 4.25% becomes 0.0425, 0.0425 times 11 years. Okay, type that into your calculator and you find that the interest earned was $2,524.50. We add that to the principal. We add this to our principal amount of $5,400, and we get the sum of $7,924.50. Okay, that's simple interest. Let's do one with, this one's compound. Good. 6 years, 7%. And we can look at our formula. Account balance equals principal times 1 plus the rate raised to the t power. Plug in our values again, and we get A equals, let me rewrite that here, 15,000 times the quantity 1 plus 7% is 0.07 as a decimal, raised to the t power, 6 years. And after you type that into your Desmos calculator, we can see that the interest earned was $7,510.96. We add that to the principal amount, the original amount, and we're going to get $22,510.96. Okay, I'll let you calculate these two on your own. Let's see, can I do one more here? Okay, let's try this one. Number 7, Shelby deposits $3,000 each into 2 savings accounts described below. If she doesn't make any other deposits or withdrawals, find the combined amount of the accounts after 7 years. Okay, so she's got $3,000 in a simple interest account and $3,000 in a compound interest account. So we could plug in our formulas. I equals the principal amount, 3,000, times a rate of 0.05 times 7 years. And for our compound interest formula, and you plug in the numbers. Principal times the quantity 1 plus 0.05 raised to the 7th power. Okay, so we calculate both of these, and we're going to get a combined total of $8,271.30. Hey, baby. Excuse me, my daughter's here. Hey, I gotta finish doing math. I'll see you in a little bit, okay? That's my 3-year-old. Okay, and lastly here, sorry, let me circle that amount. And can I do another one? Okay, let me do this one right here, number 8. Ben deposited $2,520 into an account earning 5.25% annual simple. He uses the formula below and determines that after 10 years, assuming he doesn't make any other deposits or withdrawals, his account will have a balance of $1,323. Explain Ben's error and find the correct account balance. So our formula again, we're going to run it through. Let's plug in our numbers. The principal amount was $2,520 times 0.0525 times 10. Pardon me for running out of space right here. So after we type these numbers into our calculator, we get the interest earned was 1,323. That's the same as what Ben had right there, but what does Ben say though? Oh, okay, he says his account will have a balance of 1,323, but that's the amount that he earned in interest. So what Ben's mistake was, is he didn't add this to his original amount. So we add this 1,323 to the original amount that he deposited, his principal. Okay, and what are we left with? Sorry, I'm making a mess right here. What are we left with? $3,843. Okay, so when he adds the interest he earned to his principal, that's our final result. Okay, so I hope I gave you enough information here to go ahead and finish up this page along with the homework page, which goes over the same kind of questions. All right, we'll see you in class. Thank you.